My name is Sir Arthur Eddington, and we are in the 19th century. I am famous for my work concerning the theory of relativity. I became extremely fascinated with Einstein's work after William D. Sitter passed his notes on to me in 1916. A small group of colleagues and myself came up with the project to test Einstein's theory of general relativity. To do so, we obtained a government grant for €1,000 for travel costs and €100 for instruments. The equipment consisted of 2 very large lenses and many large tubes to compensate for the Earth's rotation. Telescopes and mirrors were all working together in order to capture the image with the evidence that light does indeed bend, therefore proving Einstein's theory. We were trying to find actual supporting data to give the first realistic data towards Einstein's theory of general relativity. We ended up finding that the bending of light around massive objects is known as gravitational lensing and will become an important tool in astrophysics. Physicists now use gravitational lensing to try to understand dark matter, the expansion of the universe. We traveled to the island of Principe near Africa to watch the solar eclipse of May 29th, 1919. During the eclipse, we took pictures of the stars and the region around the sun according to the theory of general relativity. Stars with the light rays that pass near the sun would appear to have been slightly shifted because of their light and have been curved by its gravitational field. This effect is noticeable only during eclipses, since otherwise the sun's brightness obscures the effect on the stars. I showed that Newtonian gravitation could be interrupted to predict half the shifted predict by Einstein. I'm sorry about that. The experiment occurred in 2 locations. I first measured the true position of the stars in January and February 1919. Then in May, we went to a remote island off of Principe to measure the stars' positions during the eclipse as viewed through the sun's gravitational lens. I also sent a group of astronomers to measure in Brazil as well. This was because of the eclipse. If it was blocked by clouds or any other things, we would have another location to give us a better probability to execute the experiment, since the solar eclipse only happens about once every 18 months or so. So in February 26th, the Grand Canyon National Park, an act of the United States Congress, established most of the Grand Canyon as its United States National Park. In March 4th, the Communist International is founded. May 1st, a large left-wing demonstration in France leads to a violent confrontation with police. In June 4th, women's rights in the United States Congress approved the 19th Amendment to the United States Constitution, which would guarantee women's suffrage. And then they sent it to the states for ratification. In October 28th, prohibition in the United States is authorized. The United States Congress passed the Volstead Act over President Woodrow Wilson, and prohibition goes into effect on January 17th, 1920, under the provisions of the 18th Amendment of the United States Constitution. And September 3rd, Jan Smuts becomes the second Prime Minister of South Africa. Sir Frank Watson Dyson, astronomer of Royal Britain, conceived in 1917 the perfect experiment to resolve the issue of conducting the experiment. Andrew Cromwell, an astronomer in the Royal Greenwich Observatory, was my co-manager per se. He led the experiment in northern Brazil. And then Newton and Solder were also involved with the experiment through findings they found through the papers they wrote. I was the coordinator, also known as the manager, as you would say. I brought the team together and did most of the data analysis, so later released my paper a year later regarding the experiment. Even though some people thought it was poor quality, I didn't believe I had enough supporting evidence. I later did find out that indeed my evidence was more efficient and my calculations were correct, supporting Einstein's theory of general relativity. I decided to do two simultaneous expeditions, one led by myself, and that was to travel to the island of Principe off the coast of the Spanish Geneva in West Africa, and the other led by Andrew Coleman, which he was in southern Brazil. Yes, we returned to England, and our data from Principe confirmed Einstein's predictions. I announced his findings on November 16th, 1919. The next morning, Einstein, until the relative obscure newcomer and the theoretical physicist, was on the front page of every major newspaper around the world because of my practical experiment finding. Everyone now bought into the idea fully of general relativity, and it proved Einstein to be a genius, and further support that Einstein's general relativity idea is the most complete description of gravitational space-time to date. I started out as a young boy. I've always been fascinated with the stars and astronomy. Higher education at the age of 16 at the University of Manchester in 1898, where I studied mathematics, English, and literature. I spent the first year in general courses, but then I majored in physics for the remainder of my 3 years. I had then graduated in 1902 with a bachelor in physics. I obtained a scholarship to Trinity College at the University of Cambridge, where I immediately after graduation, I went there. I progressed rapidly and achieved many things, but after I received my master's, I secured a position at the Royal Observatory in Greenwich, where I embarked my careers in astronomy, and I obtained fundamental ideas for this experiment. Later, during World War I was a secretary of the Royal Astronomy Society, where I received a series of letters and papers from William D. Sitter regarding Einstein's theory of general relativity. This is where the wheels began to turn in spite of my experiment. Thank you. You have a great day.